Hello my dear students, welcome to Learning Chemistry is Easy and Fun. With this video we start on a new topic, polymers. What are polymers? So let's break up this word first. Poly means many and mer means part or unit. So polymer is nothing but a structure or a compound which is made up of many small parts or units. How are these small parts or units joined? They are joined by what we call as covalent bond. Right? So let us give it a proper definition. Large number of small molecules joined by covalent bonding to form high molecular weight compounds is called as polymerization, and the high molecular weight product that is formed is called as a polymer. This pen is an example of a polymer. This board is an example of a polymer. The plastic on the edges of the board is an example of a polymer. Polymer is everywhere around us. The cloths that you are wearing is also an example of polymer. The cotton that is there, fibers which are there, jute which is there. These are all examples of polymers. You will see polymers around us all the time, right? We are all made up of polymers, proteins, carbohydrates. These are all examples of polymers. These are high molecular weight products. The smaller units which are making up a polymer is called as a monomer. Mono means one, the single unit. Each single unit of which the polymer is made up of is called as a monomer. So we've taken the example, a very common example, polythene. Do I need to show you a sample? We carry it with us every day in some process or the other. So polythene is something which is made up of polythene, or also called as polyethylene from its previous name. Now as the name indicates, poly means many, ethene, a number of ethene molecules joined together to form the product. Now N, here N can be anything. It can be around 50 to 100,000. How does this process of polymerization take place? It takes place under specific conditions of temperature, pressure and the presence of a catalyst, which we are not detailing right now. We will talk about it as we advance in the topic. So what happens is there's a double bond over here. So ethene molecules, they join together. The double bond breaks and another ethene molecules joins over here. So I'll have CH2, CH2, CH2 and so on. Now, is it feasible for us to show 50,000 ethene molecules joined with each other? No. So how do we represent a polythene? What do we say is, we put a hyphen over here, a dash over here, indicating the presence of a single bond, that this is part of a chain. We put a bracket. The smallest repeating unit that we've got over here is CH2 single bond CH2. So a hyphen here as well, with a part of it protruding out of the bracket, and we put N over here. This becomes the representation of polythene. Correct? What is degree of polymerization? Another term. Can you guess? Degree of polymerization. How many molecules make up a polymer is what is called as a degree of polymerization. Just now I told you polythene is made up of around 50,000 ethene molecules, right? So the degree of polymerization of polythene would be 50,000. In other words, we can say that polymers are nothing but big molecules, macromolecules. But all macromolecules are not polymers. Confusing, right? We are saying that polymers are macromolecules, but we are saying at the same time all macromolecules are not polymers. What's the difference? Yes, any high molecular weight compound would be classified as a macromolecule. I gave you the example: protein, carbohydrates, nucleic acids, lipids, cotton, jute. All these are examples of macromolecules, big molecules. But all of them do not contain the repeating unit. There are molecules like lipids, chlorophyll, etc., wherein they do have a high molecular weight, but the repeating unit is not the same. Like in the case of polymers, it's the same unit of the part of the molecule which is repeated, of the monomer which is getting repeated again and again in order to give you that single product. This property is missing in the case of macromolecules. Can you find out some more examples of macromolecules which are not polymers? So we say all polymers are macromolecules, but can you complete this sentence for me? But all molecules are, all macromolecules are not polymers. Would you like to get notes of this particular topic? Would you like notes on this particular topic? If yes, then please fetch a pen and paper. Whatever is written on the board, if you copy it, they become your notes for future reference, especially when you are offline and you do not have access to your mobile phones, right? So go ahead, note this down, and we proceed with the topic of polymers.